Hello, welcome back to Decaf-Math ASMR, and welcome if you are new here. Today let's review the quotient rule, for derivatives, and let's start by going over what the quotient rule says and how to apply it, and then we'll do a quick little derivation to show that it's actually just the combination of the product rule and the chain rule. This way you can decide for yourself whether or not you want to memorize the quotient rule, or if you want to always apply the product and chain rules, unless you need to memorize it for a class, of course. As usual, just relax. There's no pressure here at all. I just think seeing this at least once is pretty cool, and that's what I'm here for. If you're not into calculus, I welcome you to check out my other playlists as we jump around and cover different topics here on this channel. Thank you for joining me. Now let's get started. So, the setup goes like this. If I have a function h of x and it has this form, something divided by something else, so f of x divided by g of x, that's when we use the quotient rule. The word quotient implies division. So this fraction says this thing divided by this thing. So the quotient rule then tells me how to actually find the derivative of this thing if it has this form. And the formula goes like this. On the bottom, I have g of x squared. So I just take this bottom function and square it. On the top, I have g of x times f prime of x minus f of x times g prime of x. And that is it. This right here is my quotient rule. So it's quite a lot to memorize, I know. If you feel like memorizing it, you can take some time and kind of stare. But once we have this down, all we have to do is fill in these pieces and plug right in. And that's it. So let's say I have a function, h of x, that's e to the x over x plus 2. So I have something with an x in it divided by something. So my top thing is going to be f of x here, and my bottom is going to be g of x, and I have my fraction. Now we don't need to get too attached to the letters h, f, or g. We just want to get the idea, because we might be given a function, f of x, and you can use different letters here. Top divided by bottom. So we just go ahead and use this formula to find the derivative of this function. So h prime of x would then be g of x is this bottom function, x plus 2 times the derivative of the top, f of x, and the derivative of e to the x just happens to be e to the x as well in this case. It's one of our basic derivative rules, minus f of x, so e to the x, times the derivative of x plus 2, which is 1, plus 0, which is just 1. And on the bottom, we have x plus 2 squared, and that's it. That's it right there. So we just clean this up now, no big deal, just a little bit of algebra. Take your time. I'm going to factor out an e to the x here, just because in this particular case I see it. So I'm left with an x plus 2 minus 1. Very nice. And then e to the x times x plus 1. 2 minus 1 is 1. Very good. Divided by x plus 2 squared. And that is our derivative. Good. So as long as we have this form, we can just plug in each of these pieces and we are good to go. Now there's this little cute, fun little mnemonic that I've heard, and you may have heard too if you are in calculus now, or if you took this, or if you've taken calculus. But I'll just share it with you here. If we call the top thing the high, as in, the top, so H-I-G-H, but H-I for short, and the bottom low, short for L-O-W. In case we're too lazy to write one more letter, the mnemonic goes like this. Low, D high, minus high, D low, over low, low. Low D high, minus high D low, over low, low. And all that is just the bottom thing. D high is just D as in the derivative, so df dx, but it looks cuter this way. Minus high, which is the upper one, f of x, d low, so the derivative of the bottom, over the bottom, meaning bottom squared. So if you like little mnemonics like this to help you memorize things, you might want to consider this one. Low D high, minus high D low, over low, low. So, the thing is though, if you don't use this formula often, or if you're not in the class, it is something that's quite complicated to remember. The main reason, in my opinion, is that there's a minus here. So the order of which thing you prime first and you keep first matters. Because if you have the wrong order, your derivative is going to be negative of what it should be. The bottom doesn't seem so bad, g of x squared, but the top is pretty important. And after a while, high d low minus low d high doesn't sound too terrible, right? So it may be useful to then consider using the product and chain rules. So let me show you here. If we have the product rule, just for a review here, we would have the form f of x times g of x, the word product implying multiplication. This one's a bit easier to memorize. Though it's a mouthful to say out loud, it's easier to memorize because the pattern is basically take the derivative of one of the functions and multiply it by the other without taking the derivative. Then add just the first times the derivative of the other. So you're always priming one, keeping the other, plus keeping the first times priming the other. So the reason I say that this one is easier to memorize is because there's a plus here. So even if you were to mix up the order for which one to prime first, it actually doesn't matter. Addition is commutative, meaning you can switch the order and you get the same sum. 2 plus 3 equals 3 plus 2, so it's okay here. So as long as you remember this general idea of priming one and keeping the other and adding the other way around, we're good to go. Whereas with this minus here for the quotient rule, if you mix them up, you're going to get a negative. So that being said, if I have this h not to be the same one as this h, but this is just a rule, right? So working with my h of x, that is my f of x over g of x. So we're going to go back to our original f of x over g of x. If I rewrite that as f of x times g of x to the negative 1, meaning I bring this bottom up here back to the top, and using our idea of exponents, a negative exponent means a 1 over this thing. So if I bring the g of x up to the top, I'll have f of x times g of x to the negative 1. Now I can basically do the derivative here using the product rule. Applying the product rule, but using it for this as my first function, so f of x is still f of x, but my other function is going to include this g of x to the negative 1. And so I'm going to just plug and chug into this formula, not to confuse the f and g's. This is my first one, this is my second, and so I'll just go ahead, take the derivative of the first function multiplied by just the second one, leaving it alone. And then I will add, leaving the first one alone and multiplying by the derivative of the second, which is, including this negative 1 here, prime, like so. So then, now we just do a little bit of algebra. So we're going to clean it up a little bit, just following it along with the rules that we know. We have f of x over g of x. So I'm moving f prime of x over g of x. I'm moving this g of x to the negative 1 back down. And then I have a plus f of x. And then now I have to be careful with taking the derivative of this thing. I haven't written out the derivative just yet. And this is where the chain rule comes in. The chain rule. So if I were to take the derivative, if this thing were an x, let's pretend it were an x. If I take the derivative of x to the negative 1, so just prime, this is one of our derivative rules. I have x to the power of some number n, and the rule is just to bring that number in front, so negative 1 times x to the negative 1 minus 1, which is negative 2. However, since I don't actually just have an x, I have a function as well, then that's where I chain the derivative of that function. So you treat it as though it's an x. So I'll go ahead and multiply by negative of my g of x to the negative 2. So it's my negative 1, or just negative x, which is actually g of x, to the negative 2, chaining on, multiplying by the derivative of my g of x. So that's the chain rule there. And now we clean it up. So we have f prime of x over g of x. And I have a minus here over on the side. So these are all multiplied. So a positive times a positive will be positive, times a negative is minus. On the bottom, I'm putting g of x squared back down. It's a negative 2, so when I put it onto the bottom, it's a positive 2. I have f of x times g prime x. And now with a little bit of algebra, one more step. The bottom, we're going to find a common denominator, which is my g of x squared. And then in order to make g of x into g of x squared, I multiply by a g of x on the top and on the bottom. So f prime of x times g of x minus, and then we keep this the same because we already have g of x squared. So minus f of x times g prime of x. Whoops, running out of space there. If you go ahead and stare at this a little bit closer, that is our quotient rule. We have our g of x and our f prime of x here, just switching orders, which is fine for multiplication. Minus f of x, g prime of x over g of x squared. So essentially, all we did was we made the quotient, the divide, into a product rule question by bringing the bottom up with an exponent of negative 1. Then we applied the product rule as usual, but then we have to use the chain rule because now instead of just g of x, we have g of x to the negative 1. So using the chain rule, we treat the g of x like it's an x, but then we have to chain on the derivative of g of x as well, cleaning up the algebra, and we get the equivalent of the quotient rule. So to show you how that would basically be done for our specific e to the x example, of course, applying this either way should give us the same answer, but this is what it would look like. If I have this for h of x, you would just immediately jump to doing x plus 2 to the negative 1. And then when you find h prime of x, I'm going to just use the product rule now. So you keep the first times the derivative of the second, which would be the negative 1 times x plus 2 to the negative 2. And then that's where you do the chain rule. So times the 1. In this case, it makes no difference, but it's important to check. And then plus priming the first, so e to the x anyway, times keeping the second. And then we just do the algebra. So we have our negative 1. So this should look very similar to the derivation that we just did. It's just negative e to the x, divided by x plus 2 squared plus e to the x over x plus 2. And now we just clean up the algebra. So common denominator of x plus 2 squared. We have a minus e to the x plus e to the x times an x plus 2, which is then just our x plus 2 squared. And I'm going to factor out the e to the x like I did before. I have a -1 here and an x plus 2, so just to mirror what we did before, and we get our e to the x times x plus 1 over x plus 2 squared, which is what we got before. So let's see here. Indeed, it is. And that's because these two methods are actually exactly the same. It takes maybe one more line and just making sure that you remember the product rule, making sure to apply the chain rule. But other than that, it is about the same. Maybe a little bit of extra algebra. So there's pros and cons there. Either you memorize an entirely new rule, or you just do a little bit of extra work. But either way, that is the quotient rule for you today. I hope that this was interesting, maybe relaxing. I will see you around for more math very soon. Thank you for joining me here in the Math Nook, and subscribe to this channel if you want to follow along. Take care. Bye-bye.